Okay, someone mentioned to me that the video notes at the end were cut off. The video had stopped, I think it was. So this is the last one, which is called Pure Substances. And I'm over here, and it would be, I think, number 10 on your notes. Pure substances have a definite, defined, or fixed composition regardless of their source or how they are produced. For an example, the gas methane, which is CO4, is a pure substance because no matter where you go in the world, you're going to find methane as CO4. It says here that the substance is a compound found deep underground in these big pools of gas under the earth or in the earth. Methane is also produced from decaying garbage. It says here both sources produce methane with the exact same composition of CO4. Methane is even produced in the intestines of cows and other animals. Regardless of where the methane, it says, comes from, it is always the same chemical formula of CH4. Okay, so whether you get methane from the intestines of a cow, rotting trash, or whether you found it deep in the earth, the methane gas will be CH4 no matter what. And it always consists of 25% hydrogen and 75% carbon, it says, no matter what. Let's keep going, almost done to the next one. It says a pure substances cannot be separated by a physical means. Now, could a pure substances be separated by chemical means? Yeah, but it's no longer that substance. Okay, so a pure substance, that's the key word, cannot be separated by physical means such as sorting or filtration or distillation. If you have a sample of a pure substance, you cannot sort, filter, or distill that pure substance into you can't break it apart anymore, okay, because it is always going to be the same no matter what. That's only one type of matter. And this is the last one. It says here, while compounds cannot be broken down by any physical process like filtering or distillation, compounds can be broken down by chemical reactions. It says here sucrose is a complex compound with the formula C12, H12, and O11. When it says sulfuric acid is added to it now, the elements that make up the source, the sucrose, are chemically separated and decomposed in a process called decomposition reaction. So like we were saying in the last slide, that when it comes to a pure substance, physically you cannot separate it, but chemically you can. But when you do that, it's no longer that pure substance. It says here compounds can be chemically broken down into their elements or even simpler compounds. And so for an example here, that sucrose, the C12H22, and the O11 could be broken down, okay, whenever sulfuric acid was added to it, okay? And then even elements, if we were to chemically break down an actual oxygen atom, we could, but it's no longer going to be an oxygen atom. It's going to be protons, neutrons, and electrons now, okay? So it's no longer going to be what it is. Now, that was the end of the notes. Please let me know or email me somebody if we are still missing something. If so, I'm very sorry. I apologize. Now, we need to go ahead and look at our unit notes. So let me go ahead and set up this video so that way it's ready for us regarding our Unit 2 notes. Unit 2 notes is over matter. We need to get through some of this basic chemistry before we can get into other things in this class. Alrighty, here we go. It looks like this. Matter. Now, I'm sorry, but my calendar is all scribbled on because I just printed one calendar out and I scribble all my changes on it. So Unit 2 notes came out in week 2. I didn't put the video out to the weekend, so right now, actually today is Saturday. They're not due until the 22nd, but that doesn't mean you wait till the 21st to do them. Okay? Watching the video notes and doing the Unit 2 notes are going to help you answer the homeworks. They're going to help you on the CK12 website, and they're going to help you on the density lab. We have a matter density lab, and then we have a matter rotation lab. Okay? So for you to be able to be successful in those, the notes, video, as well as Unit 2 notes are going to be helpful. Please have those notes with you when you're taking your online Blackboard quiz. Okay? Have them with you. That's the reason why you should print out your notes. Okay? Print out your homeworks, print out your labs, and then when I actually give you the answers for the homeworks and stuff, then you should go ahead and make the corrections. That way you have them with you ready to go. Okay? So let's go ahead and look at Unit 2 notes. They look like this. If there's any questions, please go ahead and make sure that you make a little note. That way I can get to you and you can ask me whenever we meet each other on our video Teams meetings, okay? So let me grab a pen. We can get started. Here. So first thing is, it looks like we're going to start off with some definitions. Oops. The definition of chemistry is what they're starting off with. And the definition of chemistry is the study of matter and the changes it undergoes. Okay? So the study of matter and the changes that it undergoes is the definition for chemistry. Now, the definition of matter, okay? This is something that you've learned, right, in middle school. Y'all talked about that word. Let's go ahead and talk about that word some more because it's super important. It says matter here. Oh, the definition of matter, you know it already, right? Is anything that takes up space and has mass. So it has to take up space and have mass for it to be considered matter, right? For an example, your feelings and emotion, that's not matter. What about light? Like a light bulb or light from the sun. Is that matter? Can you grab the light from the sun that's shining down and grab it in your hand and put it on a scale and weigh it? No. But we'll talk about light later on, though. It's pretty important in physics. But no. Dreams, that's not matter. Okay, so happiness and all that other stuff, not matter. Let's keep going. Mass. The word mass is super important in chemistry or any science class because mass and weight mean two different things. Mass is the amount of matter. And how do we find that amount of matter? By using a scale, and we measure it in grams. Okay, that's like the SI unit that we use, grams. Now let's go ahead and start breaking down actually what we're talking about. So this whole unit is pretty much about matter, and we're going to break it down. First thing is, we need to break it down or understand a little bit about matter regarding physical properties. Okay, so physical properties and chemical properties. We need to know the difference between those two. Okay, so physical property. Physical property, it says here, are observed, without changing the substance. Okay, there's no change within that substance. And I will definitely explain it in just a little bit more. Okay, so go ahead and write that down. It's observed without changing the substance. Now, there's two things that we do observe here. There's a couple of them. A couple important words in chemistry class. The word extensive and the word intensive. So the word extensive is changes. Now, a change is going to happen, but it's a changes with the amount. Oops. Amount. The word intensive property is going to be does not change with the amount. Now here are your examples For extensive property, what are changes that happen with the amount? Well, solubility. How is it going to dissolve? The more you have versus less that you have, right? For an example, what if you like sweet tea, but what if you're one of those people who like the diabetic sweet tea, right? You know who I'm talking about, those people, right? If you like diabetes sweet tea, that means that you're loading that sweet tea pour cup with all that sugar. Determine the amount of sugar that you put in it is going to determine how soluble it's going to happen. What's going to happen? Is it going to be able to dissolve or not dissolve, right? Versus every other person who's like normal, who likes regular sweet tea. Okay? Now, another word here, another example is mass. When there's changes with the amount, then the mass is going to change. Makes sense, right? If I cut that sucker in half, then wouldn't the mass change? I changed the amount, so now the amount of grams I have is going to change. Energy. Okay, so when you change the amount, for an example, if you are on some crazy psycho diet where you only eat like, I don't know, one granola bar a day, that's not going to be a lot of energy because your amount of granola bars that you eat is only one versus somebody who has like that burger for lunch and then they have, a snack and all their other food. Okay, they have a different amount of food that they eat. They have different amounts of energy. That makes sense? And then volume or size. If I cut something in half, which means I change the amount of it, then my volume or my size is going to change, right? So, intensive property. Let's talk about the examples here. It does not change when you change the amount. Meaning, I don't care if I have one drop or if I have a bucket of it. It's going to be the same no matter what. For an example, density is going to be the same whether I have a drop of water or if I have a swimming pool of water. The density of water is always going to be 1, no matter what. For an example, color. If I get an object and I cut it in half, it's not like if the color changes because I cut it in half, what, is it going to become lighter or darker? No, the color stays the same. Another example, melting point. Doesn't matter how much I have, it's still going to melt at a certain temperature. Conductivity, okay? Whether I have a big amount or a small amount, electricity is still going to pass through it because it's conductive. And then temperature. The temperature of that object is going to be the same, whether it's one drop or whether it's going to be, a bucket. Now, here is one way to remember it. I try to show you a little bit of shortcuts. Look at this. We have this word right here, changes. And I'm going to box that in. When we have a change, because in an extensive property, we do have a change. Intensive property, we do not have a change. So when there is a change, yes, it's extensive. Look at that little thing there. I try to show you all the shortcuts that I know in my brain, so that way you'll have them as well. Okay? Just so that way you'll have them. So, let's keep going. So the word hardness, elasticity, viscosity, brittleness, malleability, and tensile strength are all going to be examples of intensive properties. Meaning it does not change with the amount of substance that you have. Okay, now I'm going to go ahead and add a couple more at the bottom because I forgot to add them within those little 6 pictures. But intensive property is also going to be these two down here, which is going to be luster and ductile. Okay, so let's go ahead and fill in the blanks over here and then we'll get down to there. So all of those 6 plus these 2, so 8, are examples of intensive property, meaning that it doesn't change when you change the amount. Okay, so let's keep going. It says here, for an example, let's look at hardness. Hardness is how difficult it is to scratch. S-C-R-A-T-C-H, something. Okay, for an example of diamond, is very hard because you can't scratch it, right? It's not going to, it takes a lot to break, scratch, destroy a diamond. But it doesn't matter whether you got a small little bitty diamond or whether you have a huge giant diamond. They're both, no matter what, are going to be very hard, right? Unlike soap. Next one, elasticity. Elasticity is how much something can bend or return to its original shape. Right? For an example, rubber is very elastic, and because of that, it can stretch without breaking. And I like the examples here, right? Haven't you all had those like little pink erasers in school? You probably still have some now at home, right? Those pink erasers. And when you're sitting there, you can like bend them in half. Bend them in half. Don't get me wrong. Eventually, you're going to bend it so much that you're going to start ripping it and breaking it. But there is a point where you can bend it and it doesn't break. That's elasticity. Next one, viscosity. That's how you pronounce that word, viscosity. The word viscosity is how slowly a liquid pours. Okay, so a couple of examples here is pancake syrup is very viscous and water is not viscous. Water pours faster than pancake syrup. Viscosity. The next one, we're going back to the top, brittleness. So brittleness is how easy it is to shatter. Glass is brittle because it is easily shattered. It can easily shatter if dropped. Versus a piece of plywood, right? Or 2x4. Drop that, so we're probably not going to just break immediately. Malleability. The word malleability is how easy it is to pound something into sheets. Like gold, right? So they got gold over here, and gold can be used and is used very often to make jewelry. Why? Because it's very malleable. You can pound it and bend it and smush it and make it form the shape that you want it to form. Okay, and we're going to talk about Rutherford's experiment with the gold foil. He used literally gold and he pounded gold until it was so thin like tissue paper. Okay, because it's very malleable. Next one, tensile strength. The word tensile strength means how hard it is to break something by pulling it. I like the two examples they gave here. A spider web versus toilet paper. All right, you can pull on that toilet paper, it's going to break fairly easy. I understand that there's like little cuts in it, so they break sheet by sheet, but still it breaks pretty easily versus a spider web. Okay, now the last two that we have down here is luster, which means shiny, how shiny it is, and ductile is when you can pull into wire. Now, I use that word pull, but a lot of times it is kind of hammered out, pulled, and then they make it into wire. And copper is really used because it's the ductile of it, you can make it into wires really thin too and easily. So let's turn the page. So we're on this side. Now we're on the word density. Here, remember we said density. Let me go back real quick one more time. We said it over here. Density is an intensive property. Okay, so I'm going to come over here just for myself or for you. I like to jot a little extra stuff down in my notes. That density is an intensive property. Okay, just as a reminder. So let's go ahead and start writing. Density. Density is how compact an object is. how compact an object is, meaning how much matter do you have smushed into it, okay? How much matter do you have smushed into it? So it says here, a measure of how tightly packed the atoms of a substance are. More tightly packed atoms, comma, that makes a denser substance. Okay, let me see if I can zoom out a little bit so maybe you can read it better. So there we go. So density is how compact an object is. Okay, how much do you have smushed into there? Is it very dense or is it not very dense? Density is a measurement, and I like that word measurement because when we use that word measurement, that means that we're going to have to get some values, some numbers. And so density is an equation, a measurement of how tightly packed the atoms of a substance are. More tightly packed atoms makes a denser substance, okay? Because we have more smushed into it. So it says here that a ping pong ball and a golf ball are approximately about the same size. And most of us have seen a ping pong and a golf ball. But the golf ball is definitely heavier, so it's more dense. Why is it more dense? It's more dense because it has more matter compact into the same size and compared to the ping pong ball. So it says here that if two objects have the same size volume, for an example, object 1 and object 2, the one with more mass, 30 grams, is denser. Why? Because here they're both the same size, but we have more smushed into it. It's going to be denser. If the two objects have the same mass, for an example, now this is 30 and this is 30, but the one that is smaller volume is going to be more denser, okay? Versus less denser. Why? Because there's more space for those atoms to move around versus here. Here they're all smushed up together. Alrighty? So the equation for density. Density has an equation. It's on your formula chart. You have your formula chart already in your blackboard under your chemistry work. Density equals mass. Oh, my pen is dying on me. Throw that one away. Mass divided by volume. Okay? Or the shortcut is going to be D equals M over V. And that's a capital, not a lowercase letter d. Okay? So M stands for mass, which is going to be in grams or a G. Capital D, not lowercase, okay? Stands for density, which is going to have the SI unit of grams / millimeters, or it could be grams / centimeters cubed. And then volume is what the V is, which is going to be in milliliters or liters or centimeters cubed. And I know a while back, I don't know, middle school or something, y'all talked about length times width times height. And when you did the length times width times height, what were you doing that with? You were doing that with an object that was a solid. But if you used milliliters, that means that you probably used a graduated cylinder for a liquid. Okay? So looking at the SI unit for density, if you see grams per milliliters or if you see grams per centimeter cubed, you're able to know without actually seeing the object whether it's a solid or a liquid. That's pretty awesome, I think. Let's keep going. Next one now is chemical properties. So all of that we've been talking about so far has been physical. Now let's go to chemical properties. Chemical properties. Chemical property is observed by changing the substance. Okay? Another way to think of it is how it reacts. Okay? I'm going to zoom out. So, chemical property is observed by changing the substance, or it's how it reacts. For an example over here, we've got iron plus oxygen. And when those two suckers are combined together, they're going to yield Fe2O3, or we know this as rust. Okay? That's an example there. So, we're got a couple of practice problems. Let's pause for a moment before we continue to go with chemical properties, and let's practice the math that we have. Anytime we have a little bit of math going on, we need to practice it within our notes so that way we're prepared to do it on our homework. Okay, so for an example, what I like to do is I like to go ahead and when I see numbers, I need to decide what's going on. What does that number mean? Now, how do I know what that number means? This should be a little 3 above it. How I know what that number means is when I look at the actual SI unit or the letters behind the number, okay? Because a number is just a number. It has no meaning or value to me. But the moment that I put an SI unit or those letters behind the numbers, now it's like a number's last name, right? I can say Sally, but when I say Sally Smith versus Sally Anderson, now I know exactly who I'm talking about. Right? So same thing here, 15. 15 has no value to me. There's no meaning until I see the word grams. The word grams is an SI unit for mass. So I'm going to come over here and I'm going to put M because that's the mass. 30 centimeters cubed, I know that that's going to be the volume. But when I see centimeters cubed, what does that mean? A solid. Find the density. Question mark. D. So that's what I'm looking for. And I like to do this for all my problems. I like to write down what I have and what I'm looking for. So I'm looking for density. I have that equation right here. Density equals M over V. Do I have the M? Yes. Do I have the V? Yes. I can solve for this quick and easily. So this is going to be 15 over 30 equals 0.5 grams per centimeters cubed. This is my SI unit. Why? Because if 15 has an SI unit of grams and 30 is centimeters cubed, like in math or algebra class, are you able to cancel those units out with each other? No, you can't. And since I cannot cancel them out, I've got to keep both units there. Let's keep going. It says here that a 12 gram, okay, grams again. I'm going to use a different color because they're so close to each other. Mass has a volume of 6 milliliters. What does milliliter stand for? Liquid. Find the density. Question mark D. Let me go ahead and write my equation. D equals M over V. Please have your formula chart with you always when you take any quiz or test. M stands for 12 grams. V stands for 6 milliliters. Can I cancel those SI units out? No, I cannot. So I'm going to go ahead and do my math, find my answers, 2 grams per milliliter, and I'm done. There we go. Next one, 35, I'm going to go back to the blue. Milliliters, that is a volume number. What kind of a volume? A liquid. Object has a density of, they gave me the density number of 2. They told me now to find the mass. Okay. Well, I don't know exactly what math skills you have or what your teacher taught you, but when we do algebra in here, I like to simplify it the best I can. All right, so let me come over here and show you. I do this thing called the triangle. And whenever I can use it, I use it. Some teachers do this or show it as a circle. Now, this top line of my triangle stands for division. This line down here stands for multiplication. Okay, so as I continue to look at this, I'm going to look at my equation. What is my equation? Let me write my original equation over here. D equals M over V. That's my equation. When I need to put things into my triangle, I hope this helps you for algebra class as well. Cover up the equal part. When I cover that up, I can see that this actual equation itself is dividing. M is at the top, V is at the bottom. Where's the division line here? It's right here. And I'm going to have to keep them, the letters the same. So M has to go at the top because it's the top of the division. V is at the bottom. V can go anywhere down here. And what do I have left over? A D for density. Now, if I need to solve for mass, I cover up the M. What am I going to do? I'm going to get the density and I'm going to multiply it by the volume. If I'm looking for volume, cover volume up. What am I going to do? I'm going to get the mass and divide it by density. If I'm looking for density, cover it up. Mass divided by volume. And there goes your algebra already done. Now, some of us, we prefer, when you're trying to look, you can, multiply on both sides, cancel, divide. And believe me, I understand. I will definitely do that algebra when needed. But if I can shortcut it, I can shortcut it. Here, I'm going to do it both ways for you, okay? But as we continue, I like to go ahead and just do the shortcut version. Well, let me start off on this side here. I'm going to do the original algebra that you probably learned in school. D equals M over V. D is 2 equals M is my question mark, M, and V is 35. I've got to get M by itself. So what do I do from algebra class? I see that it's being divided, so I'm going to do the opposite, and I'm going to multiply by 35 on this side. Now those cancel out. I multiply by 35 on this side, right? Now I can see that M is 35 times 2, 30, 65, 70. Okay, I'm looking for mass. Come over here.